Today we are studying lesson 3-4, all about point slope form. So this entire chapter is all about linear equations, all of the different forms of equations we can use to help us solve problems. And so we have focused a lot on slope intercept. We've talked a lot about slope, and we've talked about direct variation. All of those are forms of slope intercept form of an equation, which is y equals mx plus b. Today, though, we're focusing on point slope form. And point slope form gets its name from the root of why we use it. Because if we are given a point, and if we are given the slope, we can plug those two pieces of information into this equation to solve for slope intercept, or whatever it's asking us to do. So let me give you an example of how this would work. If you were given a slope of, say, 1/2, and you are given a point of 4, 3. Okay. So we know that slope is represented by m right here. And we know that 4 represents the x and 3 represents the y. Well, in our equation, we have 2 y's and we have 2 x's. So by the time we're done with this chapter, you're going to know this formula because somebody will always ask, which one are we supposed to use? And someone will shout y minus y1 equals m times x minus x1. And that is something that gets ingrained into your mind as we do these lessons. One thing that you need to know is that the y1 and the x1 are the coordinates, or the ordered pairs. This is x1, y1. Your y by itself and your x by itself have to be left alone, because your goal is to get from this equation right here to slope intercept. Guess what you need in slope intercept? You need your y variable and you need your x variable. So these two you will leave alone. You will not mess with these two right here. And the way that you would plug them in is that your slope, 1/2, goes where your slope is in the equation, where your m is. Your x1 goes where your x1 is in the equation, and your y goes where your y1 is in the equation. So that it can be rewritten as y minus 3 equals 1/2 times x minus 4. Okay. So this is what we will be working on in this lesson, being able to identify the key parts of the point slope formula, the point and the slope, being able to plug those key points or key parts into the formula, and then being able to take a point slope equation and turn it into slope intercept equation. Okay. That's what we're going to be focusing on. So let's look at this first one. A line passes through -3, 6 and has a slope of -5. What is an equation of that line in point slope form? Well, we're given the slope of -5. We're given an ordered pair, which is our x1 and our y1. So let's identify that information over down here. Our slope is -5. Our x1 is -3, and our y1 is 6. Now what we have to do is we have to take the point and the slope and plug it into the point slope equation and write that down here. So according to our point slope equation, we leave this y alone, and we subtract our y1, which is 6. We set that equal to our slope, and in this case, our slope is -5. Then we multiply that by our x, which we leave alone, minus, so put that subtraction symbol here, our x1, which is a -3. So look what happened here. We have minus a negative, which is the same as adding a positive. So really what this equation is y minus 6 equals -5 times x plus 3. That is the way that you would officially write it here, okay? Next, what I want to do is I want to take it from point slope form and put it into slope intercept form. So here are the two steps that we're going to, and you might already be able to tell what we're going to do. We have to first distribute the -5. Okay, so the first thing that we're going to do is distribute. So let's go ahead and do that. Let's distribute this -5 to the x and to the 3. Make sure you distribute it correctly. And then the last thing we have to do is we have to move the 6 over by adding it. So our next step, and I would write these down, is that you would either add or subtract, depending on if this was a positive or negative. Okay, so I'm going to add 6 to both sides. And my slope-intercept equation is y equals -5x minus 9. So I have my point slope form and I have my slope-intercept form. Okay. Now we're going to go ahead and do example 2. If you want to try this one on your own, you can, but if you want to follow along with me, that is fine as well. If you would like to do this on your own, go ahead and pause the video, but I'm going to keep going. Okay, so a line passes through 7, -4, and has a slope of 2. So I'm going to go ahead and label those. What is an equation of that line in point slope form? So I just need to take these and put them into point slope form. My slope is 2. My x1 is 7, and my y1 is a -4. So let's write this into our point slope form equation. So I have y minus y1, which is -4, equals my slope of 2 times x minus x1, which is 7. Notice we have minus and negative here, so I'm just going to change that to adding a positive. And so this is our point slope form of the equation. Now I'm going to turn this into slope intercept. Remember our 2 steps. We're going to first distribute that 2. And then in this case, we're going to subtract. So second step, it would be to add or subtract. So let's distribute that 2 first. I end up with y plus 4 equals 2 times x is 2x, and 2 times -7 is -14. Then I subtract 4 on both sides, and I end up with y equals 2x minus 18. And there you have it. You have a point, a slope written in point slope and slope intercept. All right, let's go ahead and move on to page 2. We're now going to identify some key features of a point slope form and graph them. So we want to first determine the slope of the equation and then determine a point so that we don't have to, the goal in this would be not to have to turn this into slope intercept form. Okay, so I know that my slope here is 2/3, but extracting my point out of this is a little bit different because remember, my formula is y minus y1 equals slope times x minus x1, okay? So let's look at our x here. Our x, it looks like it's a -2, right? But really, it's telling us to subtract whatever x1 is. In this case, we're subtracting 2, a positive 2. So my x is not -2, but positive 2. At first glance, you might think, oh, well, there's a negative in front of it, so it must be negative. But it's not. Now what would happen though, say I had instead y minus 1 equals 2/3 times x plus 2. Remember, because we're subtracting up here, in order to turn this into a positive, our 2 must be a negative. Because then we would have put it in as x minus a -2, which turns it into a +2, meaning that it went in as a negative. But in this case, since this still stays a negative, this is still a negative, then our 2 is a positive. And the same goes with our y1 over here. Our y1 is a positive. Now, I know that that sounds confusing. And typically, if I have a class in here while I'm doing my video lessons, somebody will make very clear sense of how to extract your point out of the equation and make it make a whole lot of sense. So if it is confusing, please come to me and ask me and we'll go over it. I'll give you some examples. So our point here is our x and our y, which is 2 and 1. Now, we don't have to do anything with this. We don't have to turn this into slope-intercept form if we don't want to. All we have to do is plot our point and then graph our slope. So I could plot a point at 2, 1. And from there, I can graph a slope of rise 2, run 3. Okay. And then draw my line. Now, the whole point of this exercise is just to get you familiar with the actual formula so that you understand the key features of a point slope formula. All right. What I would like for you to do is go ahead and convert this into slope intercept. And then I want to show you something once you do that. So I'm going to go ahead and work on this, but you can do it on your own as well. Okay. Okay. So the equation you should have come up with is y equals 2/3 x minus 1/3. Now, the reason I had to do this is because I wanted to show you that some equations like this, where you have a y-intercept of a fraction or a decimal or whatever, are very hard to graph accurately. So this would be an example of where I wouldn't put it into slope-intercept form and graph it. I would actually pull the slope and the point out of my point slope form to graph it. Because it doesn't cross the y-intercept at an intersection, and you wouldn't even be able to clearly tell that this was 1/3 or -1/3 on the y-intercept. Okay. Let's go down to example 4. We have our slope, it's 1/2. And we have our x. Our x is 6. Now, I want to try to explain this. So if we have x minus x1, right? That's what this was right here. And I said that x is 6, then I would say, okay, then it's x minus 6, right? But what if I said that x was a -6? This is where x equals 6. What if I said x were a -6? Then when I plug it in, it would be x minus a -6, which would really be x plus 6. And that's not what this is. This isn't x plus 6, it's x minus 6, meaning that we plugged in a +6. So that's what our x is here. Let's go up here to y plus 3. Remember, in the equation, it's y minus y1. Well, what happens if y1 is a +3? Well, when you plugged it in, it would be y minus y1, which is 3. But that's not what's up here. This shows a positive. So instead, what if y1 was a -3? then we would be plugging in y minus a -3, which is really y plus 3. And that's what we have here. So what was actually plugged in was a -3 for y. Hopefully that makes it a little bit more clear. So our point then that came out of this point slope formula is 6, -3. Okay. So I want you to plot your point at 6, -3, graph your slope. Then I want you to turn this into slope intercept and write your equation down here. Okay, so let's plot our point, 6, -3. And then graph your slope of 1/2. Your graph should look like when you're done. And then go ahead and turn that into slope intercept form. And this is what you should have gotten right here. Y equals 1/2 x minus 6. Okay. Going on to page 3. We're going to write an equation in point slope form using 2 points. Okay. So remember, when we are writing an equation in point slope form, we need a point and we need a slope. So the first thing that we need to do is we need to find our slope. Well, let's look at our graph here. We could use rise over run, which makes so much more sense than using the formula, right? So I'm going to find my slope using rise over run. And up 4. And I went to the left 5, so that's a negative. So my slope is -4/5. So that's what you should have gotten, -4/5. Now, what does point mean here? All it means is an ordered pair. Okay, that's what we need here is an ordered pair. So you can choose any ordered pair on the graph. Let's go ahead and choose this one up here, -2, 3. And now we're going to plug that into a point slope equation. Okay. So remember, point slope is y minus y1 equals m times x minus x1, where your slope is m. So this is m. This would be your x1 and your 3 would be your y1. Okay, so let's go ahead and plug that in. Y minus y1, which is 3, equals our slope of -4/5 times x minus x1, which is the -2. But that minus a negative turns to adding a positive. And then we could stop there. We're not going to turn this one into slope intercept. So that's how you would use a graph to find the slope, a point, and put it into point slope form. Now, what if you didn't have a graph, but you only had the 2 points, your 2 ordered pairs? A lot of students would say, well, I would graph them and then find the slope. But you need to be familiar with using the slope formula. Remember, the slope formula, it's up here, y2 minus y1 over x2 minus x1. So I'm going to use this slope formula to find my slope. And then I'll use my first point to write my point slope formula. So I'm going to label these. Here's x1, y1, x2, y2. I'm going to plug these into my slope formula. Y2 is -3 minus y1, which is 4. X2 is a -2 minus x1, which is 1. So go ahead and solve for slope. check up here when you're done. Notice that when I solved this, I got a -7 over a -3. Well, two negatives, dividing two negatives gives you a positive answer. So your slope is actually a positive 7/3. So I have my slope, and next I'm going to use a point, and my point is going to be 1/4. Okay. So now that I have my slope here, and I have an x1 and a y1 here, I can plug that into my point slope formula. So go ahead and do that, and then check your answer up here. Now, one thing you need to understand is it doesn't really matter which point we use. If I were to convert this into slope intercept using this point, I would get the same exact slope intercept equation as if I use this point. So it never matters which point you plug into the point slope equation. It always represents the same line on the graph. All right, let's move to our last page, page 4. Okay, now we're writing an equation in point slope form using a table. So the first thing that we need to do is we need to determine the slope by using change in y over change in x. Now, you can use change in y over change in x and figure out what's happening each time, or you can use the slope formula. I like to use slope formula when I have bigger numbers like this. Either way, I want you to use whichever method you prefer to find the slope of this line. Okay, so I'm going to take y2 minus y1 over x2 minus x1. And I am going to use my top 2 points. And I am going to label this x1, x2, and then y1, y2. And I'm just going to plug these into my slope formula. So 590 minus 640 over 30 minus 10. And that gives me a -50 over 20. And then that simplifies to -5/2 as my slope. Now, the ordered pair I'm going to use is going to be this first one right here. I'm going to use this one. So I'm going to use the ordered pair 10, 640. Okay, so my 10 is my x1, and my 640 is going to be my y1. And now at this point, I am going to plug this into the point slope formula. So I have y minus 640 equals -5/2 times x minus 10. And it wants us to put this into slope intercept form. So I'm just going to start solving. And I'm going to distribute my -5/2. And then I get 25. And now I have to add 640 to both sides. And my slope intercept equation becomes y equals -5/2 x plus 665. So what does all this mean? It says that the table is showing the altitude of a hot air balloon during its linear descent. Linear descent means it's going at a straight line or a constant rate of speed, and it's going down, it's descending. And we created an equation in slope intercept form to represent the situation. So what do the slope and the y-intercept mean? That's what we're trying to figure out. in relation to this real world situation, not comparing X and Y, but time and altitude. So 665 is where the hot air balloon begins its descent. Okay. And -5 halves represents how fast it is descending. All right. So the hot air balloon begins its descent at 665 meters. Okay. And descends at a rate of, we're not going to say -5 halves. We have to make sense of what that -5 halves is. Whenever we're talking about like units of measurement or seconds, we don't usually do fractions like this. We would say that it descends to represent the negative. And then in this case, I would turn this into like a decimal or a mixed number and say 2.5 meters per second. And that is how you would describe the y-intercept and the slope. I think earlier I said that the slope represented the time. It represents the decrease of altitude per second. That's what it is. Okay, let's go to the last one for these notes. All right, the relationship in degrees Fahrenheit and degrees Celsius is linear. When the temperature is 50 degrees Fahrenheit, it is 10 degrees Celsius. When the temperature is 77 degrees Fahrenheit, it is 25 degrees Celsius. Write an equation in point slope form giving the Celsius temperature C in terms of Fahrenheit F. What is the Celsius temperature when it is 68? Okay. There's a lot going on in this problem. We know that we need slope. We know we need a point. But the question is, how are we going to find slope and the point? Okay. Now, in my mind, I want to create a table. Okay. So then I start to create a table over here. Okay. Where we know X is on this side and Y is on this side. But then how do I know if Fahrenheit is X or Celsius is X, vice versa? Well, this is going all the way back to chapter 2, where we say that Celsius temperature C in terms of Fahrenheit temperature F. C in terms of F. And if you remember when we were doing functions, anytime you see Y is a function of X or something is a function of something else, then in this case, since Celsius temperature is in terms of Fahrenheit, your Celsius is going to be represented by your Y, and your Fahrenheit is represented by your X, because Celsius is in terms of Fahrenheit. Your Y is in terms of X. We learned that back in chapter 2. Once we determine the independent and the dependent variables, we can start inputting our values into the table. So here it says when the temperature is 50 Fahrenheit, it's 10 degrees Celsius. When the temperature is 77 degrees Fahrenheit, it is 25 degrees Celsius. So we have two pieces of information here that we can use to find slope. Okay. Now, We could do change in y over change in x. And we can use the slope formula. And I'm going to go ahead and use the slope formula and take my two y's and subtract my y2 minus my y1, which is 25 minus 10, over my x2 minus my x1, which was 77 minus 50. And I end up with 15 over 27, which can be simplified to 5/9. So my slope is 5/9. Now a point, I could choose any point I want. I'm going to choose 50 and 10. And I want you to put this into a point slope equation. So y minus y1, my y1 is 10, equals my slope of 5/9 times x minus x1, which is 50. Notice here in this equation, I use my x and y. What if I were to use my c and my f? Well, c is, y is represented by c, so instead of y, I would put c minus 10 equals 5/9 times f is my x, f minus 50. So here we have a formula in point slope form that we can use to answer the final question. What is the Celsius temperature when it is 68? So it's asking for Celsius. And they give us 68 degrees Fahrenheit. So all we have to do, I'm going to write out the formula right here. I'm going to plug in 68 degrees Fahrenheit into my equation and solve for C, Celsius. In this case, I'm not going to distribute my 5/9 because I have two terms inside of the parentheses that I can easily combine. So 68 minus 50 is 18. Now I can multiply 5/9 times 18, and this is easy because 9 is divisible, or 18 is divisible by 9. And then I add 10 to both sides. And C equals 20 degrees Celsius. Okay, that was a lot of information kind of quickly. So if you have any questions, please come to help class, but that does conclude lesson 3-4 on point slope form.